Assalamu alaikum, my name is Diaz, and today we're going to be talking about amines and carboxylic acids. Yeah, man! Oh. Alright, let's get to it. First we're going to start off with amines. Now, amines have the functional group of NH2. But you might be thinking, how is that possible? I mean, nitrogen can form three groups. So how is it NH2? That's because the one bond is for bonding with something else. So that's the functional group. That one bond is used to bond to a hydrocarbon or any other organic molecule. I've drawn out one very simple one here. The naming is very simple. It follows a very simple principle. It is very easy and very simple. You're probably sick of me hearing the word simple. That's how simple it is. You have to follow the very simple principle of simply saying you have to have alkyl amine. That's it. You see the alkyl group attached to the amine group. You say that and then add amine at the end of it. So for example here, I have this as my alkyl group. This is one carbon, two carbons. Two carbons, that makes eth. Ethyl. So that's the alkyl group. Ethyl amine. So all I'm going to write is ethyl amine. Boom, that's it, that's it. It's that simple. That class, it is probably the easiest organic molecule to name. All you have to do is take the alkyl group and stick amine to the end of it. What about the properties? It can do hydrogen bonding. However, only primary and secondary amines can do hydrogen bonding. So this is a primary amine. A secondary amine would be where the N is bonded to two places and you have NH. That's a secondary amine. A tertiary amine is the nitrogen has three bonds bonded to something else. So obviously only the ones that have a hydrogen can bond. Primary and secondary can bond. Tertiary cannot. So only primary and secondary can have a hydrogen bonding. However, all of them are basic because once they dissolve in water, they will accept a proton, forming an NH plus ion. Those form some sort of ammonium ion. So they are basic, so they will react with an acid. And that's it for amines. On to carboxylic acids. Now, carboxylic acids are very interesting, in fact. They were one of the first organic compounds to be isolated and discovered. Their functional group is C double bond O, OH. That's the functional group of a carboxylic acid. You better get used to it because in organic chemistry, you'll be seeing that a lot. Now, as for their naming, we tend to use more of their common names rather than their systematic IUPAC names because, as I mentioned, they were one of the first organic molecules to be discovered, and hence they were one of the first to be named, but according to their old common names. And since we've been using those names for a very long time now, we tend to stick to those names rather than adopt the systematic style. However, just for reference, I'll give you one as a systematic style. So, over here you can see we have two carbons, and two carbons means eth, so this is ethanoic acid. Unfortunately, carboxylic acids don't have a nice, tricky, easy way where you can attach it to one name or something. So, all you have to know is that carboxylic acids end with oic acid. This is the usual suffix of carboxylic acids. So that's ethanoic acid. You can guess a 3-carbon chain will be propanoic acid, a 4-carbon chain will be butanoic acid, 5-pentanoic acid, etc., etc., etc. As for their properties, they can undergo hydrogen bonding because they have a hydrogen attached to an oxygen, so they can undergo all sorts of hydrogen bonding. And they are acidic. That's why they're called carboxylic acids. That everyone can realize that from the name only. For the reactions, there are two main, very important reactions called amide formation and ester formation. So we're going to talk about these in a bit more detail now. Now we're going to be talking about amides, amide formation and amide hydrolysis. So first of all, what is an amide? Amides are carboxylic acids plus amines will make an amide. Why? Because carboxylic acid is acid, amine is base, so hence there will definitely be some sort of reaction. Now, the functional group of an amide is an amine group attached to a carbonyl group. See, carboxyl group is a hydroxyl attached to a carbonyl. An amine is an amine. An amide is an amine attached to a carboxyl group. Make sure you remember that. That's very important. And I wrote down a formula down here of a very simple amide formation. Now this is 1, 2. 2 carbons. It is a carboxylic acid because it has COOH. So this must be ethanoic acid. Let me write that down. Ethanoic acid. As for this is an amine and it has a methyl group attached. So it's methyl amine. Methyl amine. Okay. Now what does that produce? It produces this very weird looking, ultimate complicated amide. It just looks confusing, but it actually isn't. I wrote out the condensed structure and I drew out the structural formula as well, just in case you couldn't understand it from the condensed formula. But if you try to follow along, you will see how everything does match here. Now what is this? Well, obviously I have an amide, and I have 1, 2 here. So this is my amide. So this is 1, 2 carbon. So this is ethanamide, because amide has to end with amide. So I'm going to write the name over here because I don't have space down there. So I have ethanamide, but look, I also have a methyl group attached. Since it was attached here, it's still attached to the end. So that's exactly what I have to mention. It doesn't have a number, but instead it has an element. So this will be called N-methyl ethanamide. So that's how you're going to name amides. But let's speak. But we won't have to be naming amides a lot. As for the properties, primary amides can form hydrogen bonds. For example, this is a primary amide. How do we know? Because it reacted with a primary amine. These can form hydrogen bonds, as you can see over here. Let me use a different color to show you the hydrogen bond forming group. Secondary amides cannot form hydrogen bonds. How do we know if something is a secondary amide? It's because it reacts with the secondary amine. Because you won't have this group, instead it will be some other some sort of other hydrocarbonyl group. So those cannot form hydrogen bonds. However, they will still be able to accept hydrogen bonds. As for tertiary amides, those don't even exist. Why? Because tertiary amines don't even react, because they are non-basic. If you remember from the from what I talked about earlier in this video about tertiary amines. Hydrolysis. What is hydrolysis? Hydrolysis means the breakdown using water. So we can actually reverse this process. So I can go back from an amide back to a carboxylic acid and amine using hydrolysis. What I have to do is heat the solution with a strong acid or base, add some water, and it will go back to its original amine and carboxylic acid. Now we're going to be talking about esters. Esters are formed up of carboxylic acids and alcohols. I know what you're thinking. You're saying that, hey, you told me that alcohols are neither acidic nor basic, so how are they reacting with a carboxylic acid? You're right. In this case, carboxylic acid itself is not even acting like an acid. So this is just a normal reaction rather than an acid-base reaction. So carboxylic acids are COOH, alcohols are OH, esters are COO, and that's it. What actually happens is this OH from the carboxylic acid, not the H like a normal acid, the OH from here and the H from here join together to give a water molecule. Let's do an example. So here I have a carboxylic acid. It has 2 carbons. So 2 carbons means ethanoic acid. Let me write that down. Ethanoic acid. What about the alcohol that I have? The alcohol that I have only has 1 carbon. That means it is methanol. Methanol. Now, methanol and ethanoic acid will react together to give an ester. Now, this is the condensed formula, and this is the structural formula. It's very simple to name an ester. What you do is you take the alcohol as an alkyl group, and then you name it as if it reacted with an acid. So, in this case, this would be methyl, because it's methanol. It'll be methyl, and what's the reaction with an acid? With an acid, if you take ethanoic acid, it will become ethanoate. So it's methyl ethanoate. And that's how you name esters. The acid always comes second. As for the properties, it does not form any hydrogen bonds. However, it can accept hydrogen bonds because it does have O's, which have free electron groups. So it is able to accept hydrogen bonds, but it cannot form any hydrogen bonds. As for the hydrolysis, we can reverse this process using a strong acid. This is not like amides, and amides can be reversed using a strong acid or a strong base. For esters, they can only be reversed by using a strong acid. If you heat up the solution, you put some water in, you can change esters back into its original alcohol and its original carboxylic acid. Thank you for watching. Make sure you subscribe to our YouTube channel, Meditorial, for more future videos. Assalamu alaikum.